Hello, we will practice Fama MacBeth regression today. So let's go Google Colab, create new. Okay, and then first, let's set up some parameters. So RF equals 0.01. Let's say risk-free rate. So RF is risk-free rate. And then N, let's say N is 2000, which is number of firms in an economy. And then T is, let's say, 10 years of data. So 2520, the length of period. Okay. And then DT is this one. So length of a time unit. So it is 1 over 252. So it is like one day, right? It is 1 day. So it's annualize. So when TT equal 1, it is 1 year. This is 1 over 252. It is 1 business day per year. So, and then next S is, let's say, 0.5 multiplied by TT multiplied by square root 0.5. It is the, let's say, average idiosyncratic risks. Okay, idiosyncratic risks. So let's save and execute. And then to specify the risk cover form, let's use beta true equals MP random and then random and then 1 over n. Okay, so they are like true betas of n forms. And then there's the code and move up. And then we have to import numpy snp. Okay, and then market factor. Let's generate market factor. MKT. Market factor is, let's assume market factor is annual expected return is like 6% multiplied by DT time unit, and then multiplied by NP random standard normal, and then we have length is T, so we have T multiplied by 1. Okay, so this is the market factor, market portfolio return. So return of the market portfolio return. Okay, now we can simulate the data. To simulate stock return data, open capital asset pricing model, CAPM, then data equal first RF multiplied DT, risk-free rate, multiplied by beta true, and then multiplied by, we need a market factor, and then we will add idiosyncratic part, idiosyncratic part is S multiplied by NP random standard normal, and then T multiplied by N. Okay, so data shape looks like this. So length 2,520 and 2,000 number of form. Okay, so here it is capital as a pricing model. Therefore, basically what we did is data Y is our stock return data, is Y stock return data is, in our case, it is N by T by N matrix, T by N matrix, okay? T by N matrix, okay? X is better. Okay, so T by N matrix. Well, actually, we can delete it. So this is T by N matrix, T by N matrix. And then we basically construct as what we did is we use capital as a pricing model. So by CAPM, RIT, here is RF, risk-free rate return, plus beta of I, from I, and then market factor at time t multiplied by idiosyncratic risk. IT. Okay. So this is our setting, beta, market factor, this one. So here, let me add, okay. So basically return is risk-free rate multiplied by a beta I market return. So it means the Y is basically Y is in our data, Y is basically RF plus beta. Now we have a vector of betas. Beta. Okay, but now it is the okay, we have beta, but since we have a lot of forms, so beta and then vector like this, and then transpose. Okay, transpose basically transpose, vector transpose, and then multiply the again vector of market factor, and then plus epsilon. Epsilon matrix error term. So like let's say omega. Okay. So I did something like this, basically. Okay. To match the notation, maybe to match the notation, what I can do is I can say N, this is 1, and then actually I can do transpose NP, transpose, and it is maybe more consistent possibly. Okay, transpose. Oh, and then because we want to keep the same one, so let's say NP random seed, because we are generating random number, we can give random seed, like, so whenever we do, we have the same answer. So I can give a seed for random numbers. Okay, something like this. Stories on data. Okay. Okay, so this is our data. So we regard the data given. So here, basically, we regard data given and then estimate the model on with Fama MacBeth regression. That's our goal. Okay, so let's add code. So let's do some test. So first test is some regression. So from sklearn dot and then metric import what we learned about regression, mean squared error, and maybe R square mean squared errors, and then R and then R2 score. Okay, good. R2 score. And then another regression model, import to compare it, stats models dot API as SM. Okay, we run this. So let me copy this one and then move to the top over here. Good. So first test. So let's say y equal, let's pick a particular data. So data for all year. So let's pick some arbitrary form like 13th form. Pick a forms time series data. I just pick a forms time series data. And then let's run the regression. So model. Okay, so model is linear regression. Linear regression. Okay, we can do the linear regression. And then we model fit. Model fit or fit y to market factor. Okay, because the capital is a price model. And then we print first. First we print intercept, and then we print out model intercept. Okay, and then also let's print coefficient, and then we print out model the coefficient, model that coefficient. I don't think so. Model that coefficient. Okay, and then we have only one, so the first one. And then coefficient of determination. And then print coefficient of determination, R squared. Let's print R squared. R squared. Let's print R squared. And then up to the second digit. And we will print out R2 score. R2 score. Okay, hard score. And then Y. And then in sample prediction and model Y and compare this one as model model predict MKT using MacBeth. So our fitted value, okay, this one. I will done, I think. M2 square. So this one invalid syntax and text invalid syntax. Well, this is because I don't need this one. So model now linear regression name linear regression is not defined. Strange. So I think I have to import the model. So import here, import of course, sklearn the linear model as import actually from import, and then we will import linear linear regression. Okay, linear regression. And then actually we can import pandas as PD. Import sklearn linear model. Okay. And then we have another Y model fit. I think it is the other way around. Fit Y. Okay, so intercept is this one, coefficient is, well, this one. Okay, so we can, it is estimated coefficient, right? Estimated coefficient. Estimated coefficient. So we can actually see the true coefficient. True coefficient is, of course, in the true beta. Beta true. Right? Beta true, and then it is 12. So true coefficient. This is also, yeah, true, and then, yeah, so estimated coefficient is this one, true coefficient this one, so they are very close to each other, okay? So our model seems right. For robustness check, let's, and then to practice, let's do the other alternative way. Alternatively, okay? Alternatively, let's use test model. So now X, let's define X is SM at constant and the MKT. Okay. And then let's say model equals now SM whereas Y and X. Okay. And we will fit it. Okay. And then one beauty of stat model is we can see everything all together. So print model summary, okay? And we can see everything together. So let's take a look at this. So yes, there. So let me add over here. Okay, so we have 1 line left. So ask this one. So yeah, let's check coefficient. This one constant is, yeah, they are rounding error, but yeah, intercept is this one. Yeah, they are roughly same. Okay. And then actually, even alternatively, we can do linear algebra, right? In the linear algebra, well, what we can do is to use linear algebra, we can do X, we can now define X and PC column. Okay, we can add a column to the NP ones, so to add constant T length of constant and market factor. So here, basically this X is text. Basically here, this X is, let's use big X over here. X is, looks like this one. So kind of matrix. X is kind of matrix. So actually not, it is equivalent. Okay, because it's definition. So the first column is ones, one. And then market factor x1, x1. And then 1, x2, something like this one. And then more. And then the length is t, right? So what we will have is 1 xt. So x looks like this one here. Okay, so to explain the linear algebra in our model. Okay, so in linear algebra, the betas, the coefficients are, we know the coefficients are intercept and then, okay, we know that intercept, actually, log 1, actually, yeah. And about the intercept and coefficient of intercept and then market factor is we can compute as one as, let's say there's a head beta. Okay, so our goal is to estimate this beta head equals, actually we can put everything in center. So beta head, we want to estimate beta head. The coefficient is, if you know linear algebra, then it's like x prime, actually x prime x, okay, inverse x prime y. Okay, we can write this way. Okay, so actually this is x prime x inverse x prime part, we can usually, it is write down as m. So let's say this one is equivalent to my. So M matrix is over here, x prime x inverse x prime y, then we can get the beta. So we can use this linear algebra. So we define x with ones and then market factor. So we can define M matrix. M matrix is like first inverse x prime x. Let's write down x prime x first. So x prime transpose and then x, and we have to inverse it, then NP linear algebra, and then inverse. Okay, linear algebra inverse, and then x prime. This is M matrix. Okay, now our estimated beta. Okay, estimated beta is, you can simply print my. Okay, let's take a look at it. So our coefficient is, yeah, this is coefficient for constant and coefficient for the market factor. So again, we have the same value. Here, coefficient is this one. So in the linear algebra, you get the same answer.